Hi, welcome back. And in this part of my project, I will be presenting Phase 2, Design. Brainstorming Idea 1. In this idea, I thoroughly sketched a silicone rubber casing that the live charging cable would go inside of. And in order to access the live charging cable, all you would have to do is slide down that rubber casing onto itself in order to expose the wire. Once the user is done with the live charging cable, once they disconnect the phone from the cable, the silicone rubber would automatically go back up, ensuring the coverage of the live wire. Brainstorming idea 2. And in this idea, I sketched out two hard plastic pieces, one that would go over the live charging end of the cable, as well as one that would hold this circular structure on the charging cable cord. The circular structure that is folded upon itself by the charging cord would allow less use damage, as it would provide a less stressful environment for the charger. And this would be secured by the hard plastic piece shown in the picture to your right. Next, we have brainstorming idea 3. And in this idea, I took inspiration from a medicine bottle cap where the two triangles would align with each other in order to expose the contents inside the bottle. But once disaligning the triangles, this would securely lock the mechanism, not allowing children to access the medicine inside. And I really did like this concept of a locking mechanism, so I decided to create a whole prototype design around it. Performance benchmarks. In order to determine if my prototype is successful, I did have to create performance benchmarks. And here is a list of my performance benchmarks. Next is decision-making matrix. Out of the three concepts of my prototype, I decided that concept 3 was the best. And this is because out of all of the specifications needed, the ratings did come out to a perfect score. And because of this, I did go forward with concept 3. Winning idea. The idea that won was idea 3, as it included all components needed in order to produce the safest option for preventing children from inserting cell phone chargers into their oral cavity. With the ability to prevent damage to the wires, as well as an added feature inspired by child-proof medicine bottles, this design was the most qualified for my prototype. Here is a concept sketch of my winning idea, which would include a top piece, a bottom piece, and a connector piece, as well as grooves for grip in order to ensure that the user is able to fully rotate it on its axis. The connector piece ensures that the top and bottom piece do not get lost and stays connected to the live charging cable. And as you can see on the child picture on the bottom, by having a protective casing around a live charging cable, this denies access from children to the electronic charger. Materials cost analysis. For materials, the only two materials that I needed was a 20-foot clear vinyl tubing and polypropylene filament, as my prototype is mainly 3D printing. So the 20-foot clear vinyl tubing costed $4.28, while the polypropylene filaments in total would cost me $55.12, coming out to a grand total of $59.40. Here's a picture of my CAD modeling top piece, and as you can see, I have a notch on top of the top piece in order to secure the connector piece to it, as well as the grooves provided in order to make sure that a user can fully grip the top piece in order to rotate it. On the bottom here, there is a triangular locking indicator, which will demonstrate where the notch on the bottom piece is in order to successfully disconnect the top piece from the bottom piece. Here is my top piece CAD modeling drawings. Here we have the CAD bottom piece, and here I have a hole in order to insert the charging cable into it. And once again, there's a little notch on the bottom where the triangular indicator shows. Here we have the CAD bottom piece, and on the bottom piece, we have a small little hole that allows the live charging cable to be inserted in order for it to be protected. And we also have a little notch by the triangular indicator to show where you can successfully remove the top piece from the bottom piece. Here's the bottom piece CAD drawing, fully dimensioned as well. Here we have the CAD connector piece, which ensures that the top and bottom piece are fully secured to each other, even when disconnected. Here is the connector piece CAD drawings. And here is the CAD assembly. Here we have the top piece and bottom piece aligned and connected, as well as the connector piece securing the top and bottom piece together. Here is the assembly drawing. And thank you so much for watching this portion of my project.